love math, enjoy math, learn with Alice Math.
Hi guys, welcome to Alice Math class. Today we're gonna talk about stretch. So stretch means we have two different stretch. One is vertical stretch and another one is the horizontal stretch. Let's look at them respectively. First, if the function y can be written as p times fx, where p is positive, so we call it a vertical stretch. And the p is called scale factor. The invariant x-axis means the point x-axis means the point on x-axis. That's not change. From the graphic meanings, so each point becomes p times its previous distance from the x-axis. This means the vertical distance is p times. So if p is greater than 1, which means the point moves further away from the x-axis. If p is between 0 and 1, the point moves closer to the x-axis. So now following the description, p times fx means we just times the scale factor in front of the previous function fx, which means the vertical stretch. Okay, let's look at the following description. Y equals fqx, and where q is the positive number, we call it the horizontal stretch of y equals fx. In this case, the scale factor is 1 over q. It looks like the vertical stretch. Here, the vertical stretch, the scale factor is p, the coefficient of fx. But now you see here, the coefficient of x is q, but the scale factor is 1 over q. And similarly, invariant y-axis, which means the point on y-axis, the point on y-axis does not change. So each point becomes 1 over q times its previous distance from the y-axis. So the distance from the y-axis means the horizontal distance. So if q is greater than 1, so you see the scale factor is 1 over q, which means the point moves closer to the y-axis. So if q between 0 and 1, which means the point moves further away from the y-axis. Okay, so this is the short description of vertical stretch and horizontal stretch, and they have some key features. And now let's look at the following question. Question 1. Consider the graph of y equals hx alongside. And on separate axes, draw the graph of y equals 1/3 of hx. And another one is y equals h bracket x over 2. So first, we need to know what is the scale factor for each stretch and what type of the stretch is it. So now, first, we times a scale factor in front of the previous function. Now, according to the definition, you see, if y can be written as p times fx, which means it's a vertical stretch, and then the scale factor is the coefficient of fx. Now, which means P equals 1/3, and this is a vertical stretch, which means the vertical distance will become 1/3 of the previous distance. Okay, now look at the following graph of HX. So what we see here, they have some short line, and then we'll find some key point on this graph. For example, what we'll see here is -3 and the origin on the x-axis. And then we say the vertical stretch, which means the point on the x-axis should keep the same. So -3, 0, and 0, 0 should keep the same. And then now look at some other point. For example, here. Here, this point is -2 and 3. So the vertical distance is 3, but now the scale factor is 1/3, which means the vertical distance now changed to 1/3 of the previous distance. So now this point should move to here, only 1 unit. Okay, and also here we have the similar, so the vertical distance now from the 3 unit to 1 unit. Okay, now move on to the right side of the y-axis. Here, this point, and we see here the vertical distance from the x-axis is here -3, which means 3 unit, and now we need to change it to 1/3 of it, so which means the point in here, move here, and also we moved to here, this point. The last point is here is -3, -4, and -5. Here is a -5, and then is the 1/3. 1/3 here is 1/3 of the previous vertical distance, means 5 times 1/3, so is 5/3. Probably here. You can draw it here. Alright, so now we can collect each vertex. We'll find the new graph of 1/3 times the HX is here. Collect each vertex. Alright, so the blue one is the new graph of y equals 1/3 of hx. So here is y equals 1/3 of hx. Okay, let's move on to the next one. Y equals hx over 2. So here it means the horizontal stretch. And then the scale factor. Here the scale factor is 1/q. So previously q is the front of the x, so it's a half. Now 1/q, which means it's 2. Scale factor equal to, which means the new distance is 2 times the previous distance. Now look at each vertex. So the leftmost vertex is -3 with the x coordinate, which means now the horizontal distance from the y-axis should be 6. So now we need to move on to the left side to -6 point. And also you see here this vertex, and this vertex, the x-coordinate is -2, which means the horizontal distance is 2 units. Now we should move to 4 units. So it's -4. So -4, all right, is here. And this point you see the x-coordinate is -1. So now we should be double the previous distance. Now we should move to here. And then this point you see at the origin, which means still on the y-axis. So it's invariant. It keeps same. Your case should keep same. And then now this point, the x-coordinate is 1. Now the horizontal distance to be twice. So it's here. And then the previous one, this point, and we have the x-coordinate is 2. So now we should move to 4. So point should move here. And then the last vertex, and then here is 3. So which means the horizontal distance is 3 units. Now we should double, move to 6. Finally, we connect each vertex together. The new graph is this is a new graph of y equal h x over 2. So you look here. So the green one is the horizontal stretch of the black one. And then the first graph, you see actually the blue one is the vertical stretch of the black one. Because here the scale factor is 1/3. So you see here, seems like the compress, right? The compress. Okay, so this is for the first question. Now let's move on to question 2. The question 2, they give us the graph of the gx and fx. And then they didn't give us the equation of each graph. So the question asks us to write gx in terms of fx. So inversely, so how do we find some key features from each graph? Look at here. The black one, we have a point here with the x-coordinate 0, the y-coordinate is -1. And you see here, we find another point lying on the red graph, and then with the same x-coordinate 0, but now the y-coordinate is -2. So which means the vertical distance is 2 times as the previous one. Previous one is 1 unit, and now it's 2 units. Okay, so now we can have a look for some other point. For example, here, I choose a point here, and then you will find the x-coordinate is 2, and then the y-coordinate equals -2. And on the same vertical line, I find another point. Still have the same x-coordinate 2, but now the y-coordinate changed to be -4. So previous vertical distance is 2 units, but now the new distance is 4 units. It's still double. Okay, so which means from the black one to the red one is the vertical stretch. And then the distance is 2 times the previous one. So which means scale factor is 2. So normally we can write the new function equals a scale factor times the previous function. So now the scale factor is 2, so should times 2, and then fx. Okay, now let's look at the question B. a common point is both on black one and the red one is here. And this point is on the y-axis, which means the point on the y-axis does not change, right? Okay, so, and then look at the other point. So this point, now we have the horizontal distance of 1 unit because the x-coordinate equals -1, only 1 unit. But now, on the same x-axis, you see here the red one, and we find the point with the x-coordinate -3, which means it has 3 units distance from y-axis. Previous one 1 unit, now it's 3 units, which means it's 3 times the previous one. And symmetrically, you see on the right side of the y-axis, the previous one with the x-coordinate 1, which means 1 unit from the y-axis. And then now we find another point on the red graph, and you see a 3, x-coordinate 3, which means 3 units from y-axis. It's still 3 times at the previous distance, So, which means compared with the black one, and we find the red one is have a horizontal stretch. The scale factor is 3. So normally we can write as y equal f bracket qx, and then the scale factor is 1 over q. So in this case, which means the scale factor 1 over q equals 3. So q equals 1/3, equals 1/3. Okay, now we can write the gx in terms of fx as gx equal fx over 3, which means 1/3 of x. Okay, so this is the whole procedure of today's tutorial. If you have any other topics, if you like me to explain, you can leave it in the comment section below. Keep on learning, and I will see you all next time. Don't forget to like and subscribe. Bye.